Welcome to the safari, the annual site safari. I have some objectives to cover. I'm going to spend a bit of time sort of introducing sites as some, in case you're new and you don't know what it is. Then I'm going to communicate kind of what I've been thinking about in the last year. Yeah, it has been a year since the last one. And then leave some time. I'd really like to explain kind of what's in flight and what my plans for site are, and then perhaps later in the month we might have a retrospective of all of the different usages of site within JUXT and people's feelings and thoughts and criticisms of it thus far. So a bit of history really. Site started in, I guess it was a lockdown project. The idea of using XTDB to store web resources, I think, dawned on Lucio and I. We didn't really go that far with the idea, but that really was the seedling of the idea that became site. And the first commit was September that year. If we roll forward to 2021, I had been kind of thinking and working on the foundations of site for a number of years. And I presented this slide in a talk that I gave in 2021. And it kind of traces a journey all the way back from, through Yada and Biddy and Liberator and all the times I've been kind of really trying to tackle this problem of building a compliant web server. So site is definitely of that kind of tradition, and it's kind of a culmination of a lot of thinking over the years. And in particular, the technologies, JUXT and REAP or PIC and lastly Grab, those are all libraries that are still in site. So kind of site is not really that new. If we continue the story, this is very much from my perspective. I know there's a few of you have kind of taken your own site journeys and built things and sort of done a lot of projects and work. So this is really much from kind of my perspective. This time last January, I was thinking about, could we replace JUXT Land which is our timekeeping system and does a little bit of holiday management, and it kind of looks and feels a bit like an HR system. So Joanna and I went away and started thinking about, could we create a replacement to JUXT.land, and we termed it JUXT Home. And this kind of was the presentation that I gave last year. It was kind of an interesting project, but if you're going to build an HR system, you quickly run up into this problem of privacy management or data that not everybody should see, dietary information, consent. And that really led me to think, well, there has to be some deeper, more general solution to the problem of access control. Up until this point, we had access control on endpoints. So every single endpoint, every single URL could have a rule that ran against it. But when you have something like GraphQL, and we really wanted a GraphQL interface to this system, you then get this problem of, well, the GraphQL endpoint is just one endpoint. You can secure that, but what about all of the results that come from GraphQL queries? So anyway, that led me to this sort of idea that if you can solve the access control problem, you can go back to this idea of having one place on site for your data and keeping everything kind of in one big graph. I'm a big fan of links, and I'll talk about why that is later on, but graph databases are very much full of links. And then this idea that if you could create a headless thing that would store data, you could then create a kind of menagerie of different animals, different clients that would talk and share this data. A lot of my, the observations of complexity and in different places I've worked is that people keep the data separate. And I think one of the reasons that people keep data separate is because they don't want to share it because of access control requirements. So by tackling access control head on, wanted to get back to this vision of having a single data nucleus surrounded by a set of very different, very customized applications. And that was really something I presented at Allwood House, that vision, which I termed atomic architecture. This was our kind of GraphQL demo. And Alex built one of these animals, I think late 2021 or into 2022. This is a very kind of early version of the slide. It's much more sophisticated than this, and we actually use it internally in JUXT, and it's running against a site instance. So I was really, really impressed and pleased about this hiring board and the fact that it was actually a useful tool for JUXT, because it was the beginnings of, or at least it was evidence that this vision that you could have multiple apps talking to a single data nucleus might work. So at the end of 2021, I kind of had three questions really about reviewing the progress of site. The first one was, well, is it enough to just put security endpoints? And that was a firm no. For GraphQL, it's just absolutely clear that you need to have something deeper at the level of the data element itself. Then there was a question, should site have a user interface? Should it be a kind of normal HTML content server? Could we run JUXT.Pro on site? I began thinking, well, that would be a great idea. But I feel now that site should really have a very narrow scope and be headless and allow you to write client applications that you can then host on Netlify. I was challenged that was something that Alex kind of challenged me on, because he was deploying the hiring board on Netlify and other edge solutions. And we were building our website in a static site generator technology called Astro. And I think actually I've been convinced that that is actually the right idea, that the developers should be focusing on user interfaces and deploying those clients in separate places, Netlify, Cloudflare, all those kind of places, and make use of those platforms. And yet site can be this island where those clients come back and share and access a single set of data. And then the third question was, we had a lot of idioms in site, especially around GraphQL. We didn't want to add code. I wanted it to be a fairly no-code, easy-to-use solution. But I felt that there were some intrinsic limits. And then thinking about our time data form code kind of idea, I was in a conversation with Alexis Vincent where we kind of ran this thought experiment about, could you actually put code out, code we put in GitHub and code bases. What if you did take this idea of timeline seriously and put your versions of code into a database like XTDB? So that was a question I was toying with, and I just for fun really gone and said, yeah, let's go and do that. So site is narrow now. It's a resource server and actually an authorization server. So it fulfills those twin roles. And on the site README, I'll talk about the site 2.0, or the latest site the site version I'm working on. It talks about this in a very technical way, that it's trying to be an OAuth 2 resource server and authorization server. So what are these things? OAuth 2 came about because applications wanted to access the data that belonged to you, and it was asking for your password. An application, like, you could go to a website and it would say, well, what's your banking password? Now, no one in their right mind would give a banking kind of support app your actual banking password. That would be too risky. And also it meant that if you ever needed to change your password, you have to go around all these different apps and tell them that you changed the password. So that would never work. So the designers of OAuth 2 came up with this clever scheme where the access was via an access token that was issued by a third party. In this case, the third party is this authorization server. So the first party here is the client, the second party, the resource server. These are the two talking to each other, or the client getting resources and data out the resource server. But the authorization server is this third party that's issuing access tokens on behalf of the owners of resources in the resource server. It's a bit hard to get your head around, especially when we start talking about authentication, which is layered, or OpenID authentication, which is layered on OAuth 2, and then it gets really complicated and nasty, but we'll talk about that in a moment. So I've kind of surfaced all the work that I've been doing in 2022 on this kind of very long-lived branch I called the Actions branch. And rather than merge it back into master, I was keen to keep master stable and available for developers working on client projects. I felt it was very wrong of me to make kind of breaking changes and migrate new stuff, untested experimental stuff, against a code base that people were really relying on to deliver client projects to deadlines. So I've kind of rather celebrated having a long-lived branch. But now I have moved it to master, only it's not the master, it's a master of a new repository. I apologize. The work that I've done in 2022, though, I have managed to surface. I kind of had a good few days over Christmas to get most of the work finished. So yes, I built this resource server and authorization server, which I'm going to demo in a few minutes. I've created this new concept called actions. Everything, every read, every write in site is mediated through access control governed by an action. So if you want to do anything, you get denied by default unless you have the rights to use an action. And actions are really like, you think of a domain language for your system. They might be things like add passport evidence, create new bank account, all those sort of things that you see in event sourcing applications. And in fact, the actions, because every single change to the state of the database is made through actions, you can log them. And by logging them, you're calling them events. You can name them into the past tense. But the important thing is that you have a log of not just when a change has happened, we get that from the bitemporal timeline, but who made the change. So when, who, and a space to record why. And then finally, something that I think will be welcome news to people who have struggled using site and deploying. With site, we've had this deployment story where we just keep uploading the same resources over and over again, and we kind of manually track which ones are out of date. So if you make a change to a site resource, then you then use the site command line tool to put that resource. And whilst we've got some tools to make that a nicer process, I've moved Site 2.0 to a package-like model. So you think of this a bit like Arch Linux, where every resource is contained in a package, and that those packages are a la carte. You can choose what kind of functionality you need. So things like the OpenID authentication or the two authorization server, all of these different user models, they're all captured in different packages, and you can choose which ones that you want to install. Actions are actually just common or golden site resources, and site resources, as you may know, are entities in XTDB with a particular constraint that they have an XTID as a URI. Everything in every entity has a URI, and then every site entity and every XTDB entity is a map. So this really is a system that is built entirely out of maps. Now, this makes the system very easy to query, to manipulate, to use tooling, very, very tool friendly, because when everything is a map, you then have all the capabilities that we have in Clojure to manipulate maps and the capabilities within XTDB to query those maps. So it ends up being a very open system. I also mentioned the rules, and yes, actions can call out now to code. Yeah, at times where the declarative rules are not enough, when you want to do something a little bit bespoke. It might be that you want to create 2 documents in the database on a given request rather than 1. Then you call out to some code. At the moment, I did actually toy with a stack-based language called Flip, which I rejected. It was kind of too hard to get your head around and write programs in. But I gravitated quite quickly back to Clojure, but using Psi, Psi is an embeddable Clojure. It's interpreted, which makes it still fast, but it gives you sort of much nicer stack traces. But more importantly, you can run it as a jail, as a sort of container. You can decide which functions, which Clojure functions and Java classes are available to your scripts. So it's very good for sandboxing. In fact, Psi is almost ideal for this kind of project. So also, this code not just runs in a sandbox, but where it mutates the database, it runs in a transaction function. And this means that the code then gets access to the very latest version and state of the database. So you're not making decisions on stale data. There's a very important quality that isn't found very often these days in systems, but it allows you to stand by decisions you've made on the basis that you've made it on the very latest available data, rather than some sort of old stale cache copy of the data. This is a very important principle for keeping systems simple. Anyway, we touched on this, is that I think one of the constraints of atomic architecture as well. So Site is really being pitched, I suppose, by me as a reference implementation of the nucleus of an atomic architecture. So yes, I did put code in the database, and I know many of you feel that is a wrong move, and it's dangerous to put code in. The code should belong in GitHub. There are some mitigations here, so I don't want to labor that point too much. The code base is much improved, much cleaner, much less experimental. There are a full set of tests. The tests are much easier to read. The tests use packages. Packages have got dependency trees, so it's quite easy to write a brand new test. Start from an empty database, create just the scenario that you want to test for, and then tear it down afterwards. I've done some changes to the keywords. I've removed the alpha key. I know that looked bad on client sites that were alpha everywhere, and there was a confusion about what was cite and what was pass. Pass was really the kind of you shall not pass authentication or access control mechanism, which I had a plan to sort of spin out as its own kind of authorization library. That's no longer, that plan has been shredded. So the keyword terminology was just confusing. And the site is really quite small. I chucked a lot away, moved a lot over to packages, and with the embeddable code, the actual core kernel of site is now around 3,000 lines of code, depending on your code style. My code style tends to be quite verbose with a lot of lines, narrow columns. So I think you could actually probably reformat site to 2.5K. But anyway, it's not a lot of lines of code. Are there any just quick questions on that material before I'm going to demo the resource and authorization server now? Anyway, do flag with that.
I would have a question.
Okay, yeah.
What exactly is headless in the context of sites?
Yeah, headless, it's a word that's been popularized by content management systems. So WordPress is a content management system where you go to wordpress.com and you click around and you create content. There's been a new generation of content management systems that are called headless ones, because you can upload from the command line, you can put them into Git, but the actual content management service doesn't have a UI. It just might talk GraphQL and that's it. And so you have to use a different UI, and then potentially you have the choice of different UIs. With WordPress, you only get to use their editor. With a headless CMS, you get to use multiple editors. So by calling it headless, I'm really saying that site only talks through APIs, and it will only respond to you if you have an access token. And now that doesn't mean to say you can't put content into site. You can, because it is just a web resource, but the focus is on allowing, rather than site serving all the UIs, that it's really a bit like a headless CMS where you can have this multitude of different applications doing the UI, which are then making GraphQL and REST API calls back to this headless thing. Okay, thanks, Jan. Okay, all right, I'm going to try a demo. Software demos usually go wrong, but anyway. So I've got an Nginx running on a web server running on my machine that is running a domain called swagger UI.site.test. Now, this is not served from site. Site can be down and this would still work. In fact, it's not able to find this resource. I've tweaked the config of this Swagger UI. I'm presuming everybody knows what Swagger does, but it's a kind of API visualization tool. You give it an endpoint, which is the description of your API in open API syntax, and it will then render that for you. Now, I have another server, which is the site server, which is empty at the moment, but it's called data.site.test. Now, you might want to call this apis.site.test, or I call it data because I quite like that idea. But if it was just serving APIs, you might call it that, or you might call it atom.site.test. This is where the data lives. Okay, so two different URLs going on. Now, I've got an empty database. This is a REPL into site. Now, site, you can imagine, is this service somewhere running on the internet. It happens to be running on my machine at the moment, but it's very much an appliance that we took to, or software as a service. That's what it's intended for. It can be run as a Deps.Eden project, just like XTDB, but I'm really trying to make it possible to run on a kind of Kubernetes or a server where your only interaction with it is through a REPL, and that's only if you're an administrator and you have to have some way of bootstrapping the system. Okay, so this is completely empty of any resources. So I'm going to initialize the system. I'll explain this recipe, this is my own kind of helper really, but it resets the system, it installs some base packages here, and then it makes some registrations. So it is registering that the Swagger UI that we're about to use, that is saying that's a client, and I'm going to give that client its own client ID, maybe a client secret, and I'm going to ask it to tell me what its redirect URI is. These are 3 important configurations that you might see if you were registering an app to talk to a GitHub API or a Stripe API. If you use OAuth 2, I'm not going to go into OAuth 2 details before, but in the Q&A, if you want me to demonstrate registering an app on GitHub, it's kind of very, very straightforward. Then there's the authentication. The system, when I ask it to authorize my app in order to access the API, we're going to authorize Swagger UI, but it doesn't know who I am at this point. So it's not going to authorize an app on my behalf unless it knows who I am. So there is this 2 steps of registering a user. So I'm registering myself, but only 2 pieces of information about myself, the issuer and my username within that issuer, which is called a subject. Those 2 pieces of information give me a unique identity in the world. So I just need those 2. All the other things, mechanics, where site has to go off and download the OpenID configuration, has to download some security keys and certificates to verify JWTs. All of that stuff is done behind the scenes. And in fact, if we list these resources, some of these things that you'll see pertain to the issuer and the configuration. Okay, we have an issuer here, and that will probably be populated with all kinds of cryptography keys. In fact, I'll just have you can see all this guff. Okay. Now you'll see most of these resources, auth site.test, these are the resources for the authorization server. Remember, the server that's going to be issuing access tokens. And then finally, at the end, we have some that are going to be receiving the access tokens. Now, these 2 servers could live in the same site instance. They could be in different site instances, but they do share the same database because the access tokens do need to be kind of agreed upon. All right. So now we go to this user. We'll go back to our Swagger thing. And now we see that the Open API is now part of data. It is there. We can see it here. This is the description. Okay. In Site 1.0 or Site Master, we used to upload a document, this document, and then there were 2 code paths inside. One that would check if the resource was actually one of these routes in a Swagger document, and then another, and if it wasn't, that would go through a different code path to look to see if there's a document in the database. That meant that there were 2 different code paths inside, and one which was called Apex and one was called Site. It was confusing, and it also had led to some discrepancies. So what I've decided to do is just say, well, okay, let's keep this document as a kind of skeleton document. Let's keep the headers. Let's make that its own document, its own resource. But these individual resources like /actions and /users are actually separate resources just on their own that define what methods that they respond to. And they act just as common or garden site resources in the database. And so what we're seeing here is the stitching together a little bit of a tree walk, that building this information up again. It's not Swagger generation, though. It's almost like a hybrid of design first and code first. But that was just really a footnote. Okay, so let's see if this works. let's try and find all the users in the system. I've only got 2 API endpoints because I'm still working on this, and I don't want too many to have to go and change each one if I make a design change. So let's try this out. So we're going to issue a get to /users endpoint. What we see there, it didn't work, right? And it didn't work because we're getting a 401 unauthorized. Okay, if we get it unauthorized, what can we do about it? Well, we can click on this authorize button, which is part of the Swagger UI. And because the description has down a little section down here called the security schemes section, whereas an implicit flow, an authorization URL, there's enough knowledge here for the system to introspect, to fill out these fields. Okay, so what we're going to do now is Swagger UI, the client, is going to talk to this authorization server, and it's going to ask it to turn us to our redirect URL with an access token for us to use. Okay, so let's click on those scopes. A scope, by the way, in this context, is just a collection of actions. There can be thousands of actions in a system, and you don't want to ask a user to tick each one, just in the same way you don't want to ask a user to tick every single advertising partner you might have on your website. You want to clump them together in easy to click on clusters, and that's what I've interpreted scopes to mean. So a scope might be make administrative changes to the system, but right now they're just like read actions and read users. The reason we get a choice here is that we might not trust this application. It might be a banking application, and it might want to make payments for us, but we may not trust it. So we might say, well, it's okay to read my bank account transactions, but I don't want you to make any payments on my behalf. And in that way, I'm protecting myself from any kind of bad code or misbehavior of that client. Okay, so I'm going to authorize, click on authorize. Now, because the authorization server doesn't know who I am, it now uses its OpenID. It becomes a client itself of another server, which in this case is Auth0, but it could be any OpenID compliant server. So I'm going to log in with my GitHub credentials. And now we've come back to Swagger because we've been redirected, and we now have an access token in Swagger UI's client state. So now we can click back on the actions where we had a 401. We could try it again. And here we have our response body. We've been authorized, and we can make a request. If we have a look, see what's actually happened, we look at the curl. The Swagger UI client has now added a bearer token. It's used the access token, and it's using the standard HTTP mechanism to send it. Have a look at that bearer token. I have a REPL function called access token. I'm going to slot that in. And now what this is doing is telling me everything we know about the access token. What I'm demonstrating here is the openness of the system, the openness of the system to be interrogated and queried. Most code bases don't have this because all the information is wired into the code, into functions, into data structures. It's all kind of hidden away. And the only thing that the application exposes is its public-facing API. The benefit of databases is that they're open for anyone to query, to go in and to, for example, if we wanted to make a sitemap on our website, we don't have, we can do that in just one query and collect all of the available paths. So, you know, this is something that we know is useful, and this is something Rich Hickey talks about a lot. And there's a very nice presentation by Jack Rusher at Strangeloop last year, which we should look at, which just talks about the difference between open live systems and dead cold batch processing systems that we tend to build. As closurists, I think this is the kind of style of development that we should be really embracing. Anyway, this access token, I can see this, it's only issued for one app, the Swagger UI app. It's got a subject, which is me. These are my claims that I made when I logged in. I can check things like, was my email verified? Am I that trustworthy? My user identity, so this is matched the subject with a pre-registered user identity. So as a user, I can have multiple identities, and then here I can see my name. and all the way back to what package actually installed my user identity. This is the token and the type. If I want to show you the code for this access token, got it here. You can see that it's just a very simple function using XTDB pull syntax. It didn't have to do very much because you're just doing this like a nice graph traversal. Okay. All right, we're almost done. So what is site? And I've come across this term backend as a service, which if you Google it, there's quite a few products in this category. And I think it's quite a useful term because particularly front-end developers, it's a sort of term that's pitched to front-end developers writing those kind of Jamstack applications who want to focus on their JavaScript, TypeScript, and do some wonderful whizzy mobile apps. But they don't have time to build a backend, or they might have not be in a company where there's a team of developers building backend APIs, but they need a custom API. So there are things like AWS Amplify and those sort of things in this category. And I think this is quite a useful term, but the problem with many of these backend as a service is that they're quite ropey and constrained. They don't really do very much sophistication, and you run out of, when they don't have a particular feature that you need, you're left hung and dry. And this is always the problem with low code, no code systems. But I'd like to believe Site is a lot better than that. But of course, it still has the constraint that you're writing your system as a set of database resources, which in itself is quite a wacky idea in the first place. But I think also what Site has over and above many of these backend as a service tools is a very strong, good story on access control and audit, undo, the bitemporal stuff, the safety that you get, which if you're dealing with patient records or private information like that, is actually a strong tick box in many systems. Okay, so to finally just touch upon access control. Over Christmas, I was reading this book called Weaving the Web. It was published in 1999, authored by Tim Berners-Lee, who's kind of the renowned inventor of the web, really. And it's interesting to read the early story of the web and what the context of where the web came from. So I kind of made a few notes here that when Tim Berners-Lee arrived at CERN. CERN was this community of hundreds of different groups from different countries around the world, groups of physicists, and they would all bring their own computer kit. Some would use Macs and some had PCs, some would use Amigas. They had a wealth of different formats, incompatible systems, even network stacks were different. They couldn't even network their machines together. So what the web did was so extraordinary in that environment was to link all these systems together. And it was a really interesting story about how it didn't take off. It had a lot of constraints, but the ability to organize knowledge between and share the results of different physics experiments between different groups was extraordinary, right? It had just never been seen before. Before, you just have to go through all these kind of torturous processes. And for Tim Berners-Lee, this idea of a resource was that resource is just the target of a hypermedia link. Hypermedia is so important in Tim Berners-Lee's thinking about knowledge. And in fact, he wanted to build this web of information so he could trawl it. His argument was that intelligence, or knowledge at least, is just the graph. It's just the set of links. Our brains are just neurons that have synapses between them. It's just links. And if you knew what all those links are, you can represent knowledge as a graph. And he thought that this was going to herald a kind of new dawn of artificial intelligence. I was really struck when I arrived at Deutsche Bank, but before that, some large organizations, how difficult it was to find stuff. You might have a trade that was made and it would be stored in a system called Summit, and you'd have to, from the trade ID, know quite a lot, not just have all the authorizations, but you'd have to have a lot of knowledge how to access the Summit system, which fields to go down, which menu items and menus you'd have to navigate in order to find that trade. that's really just like what CERN was like. If we had a link which allowed a URL that allowed us to click on that and share that trade with somebody else, and it was universal, how much better, how much more productive the bank would be. The only fly in the ointment there, and I believe this is probably one of the reasons why the web never penetrated in its original form into large organizations, was two reasons. First may have been because of access control. It's just, you can't make that summit trade available to everybody in the bank. There's all kinds of reasons why not. So if you don't have access control, maybe if you don't have a general solution to access control, well, maybe your access control is just through giving people torturous processes and logins and different standards and things, and making it hard for people to access the information. The second one is that, and this is, I think, like a new insight or observation that I'm working on, and that is, I think as developers, we've actually not done a good job of making resources, these targets of a link, cheap to make. At the beginning of the web, a resource could just be a file sitting in the web server. What developers have done through Common Gateway Interface and our web frameworks is that we've actually made every resource a function or a handler, or we have to kind of program. There has to be a program implemented and maintained by a developer for every single resource. And now I feel that is overly expensive. And this was a discussion I've been having with Billy, who wrote Liberator, that I used to be in touch with. Actually, routers are actually not a good thing. They're a terrible idea. And what we should go back to is giving things real IDs. So that's a kind of back to why the system does look like this, where you can list every single thing in site actually has a URL. And the only reason you might not be able to access it is through an access control restriction. Okay, I think I'm just about out of time. Thanks for listening to that, and I hope it was useful. If you're interested in this stuff and you haven't already done so, we talk about site on the site channel. Do send me a message if you want an invite to that. And then I have created a new organization, partly because site is now, that Swagger UI, for example, needs to be on its own project. There's a need now for site to have an organization so it can host a number of repos. So I've created one of those, and I have put the new, my branch anyway, into that organization. So go check that out, and you should be able to run it yourself. It should be kind of self-explanatory, but let me know if you want to play around with it. Again, this has come out of a bit of a hack over Christmas. So there's still a lot more that I've kind of working on, but I'm pretty happy that most of the foundations are built now, and I'm just kind of building out the rest of the functionality to get it to feature parity to what we have in Site 1. Okay, any questions or complaints or feedback?
How did you get a keyword to do stuff in the REPL?
Yeah, it's a good question. When I launched the REPL, runs this REPL server, and this REPL init function is when site starts. There's a JVM arg. This is a way that you can register your own REPLs so this is a closure thing. You give it a port, and then I give it the accept handler, which is this REPL handler, which is here. This has actually copied out the closure core code base. So you can give it 4 functions that you want to override. So this is how you give it the pretty printer that I have. And then in the REPL read, I say handle input, and I say if it's one of my keyword commands, then handle it. There's actually there is a precedent for this, because this is how REPL, if you ever on a REPL and you type REPL quit, this is actually the original code. So I've just put in my own. The original functions still exist. So if I write users or actions, you get the more closure-like equivalents. But I've kind of made it a little bit like the PGSQL console to make it kind of easier for admins and ops who will be afraid about parenthesis.
I have a question, which is you mentioned having code in the database, and I was wondering if you could give some color on that, because I found that interesting and I'm not really sure what you were referring to there.
Yeah, if I have a look at an action, let's have a look at this, assign role. So assign role is an action that will take an input, a user and a role, and it will make an assignment. So that person is in the role. This is what I mean. So this assign role is mutating the database. It has a prepare and a transact. This is going to run this code in a transaction function. The reason why there's this prepare and transact phases is because in XTDB, this code, the transact code gets run on every node. So if you do things like coming up with a random number, you're going to get 3 different random numbers on each node, and there's going to be a conflict in the database, and the index is going to be different. So you have to have a way around that. So I have this prepare, which is run on the node that the request is running on, which does enough, but doesn't access the database. So it will prepare like a random number. It's a bit difficult to see, but it's actually this make nonce. I will load up this code here. This is where it is. I will actually load it up in the source because it's harder to see with so this is what it looks like. So you can think of this as a sort of mini namespace. We're used to writing code in namespaces and putting them in different places. What we're doing here is putting code in a resource. So we're kind of pretending that this is file system, and this is the prepare step, and this is the bit where it's manufacturing a URL. Now, because this is another thing, the example.org is actually an invalid example.org. It is an invalid domain name. In fact, a DNS router will not route it. So it's something that it gets replaced by the when you install a package, you provide what this example.org is going to be turned into. So you can relocate packages, and indeed you could have this package installed multiple times if you were building some co-resident where you want to have 4 projects or 4 clients all on the same. You want to save some money on your hosting infrastructure. So that was my hopefully ultimate solution to this very common complaint about site of the URLs being absolute and getting in the way and using relative paths. The reason I didn't like the relative path solution is that if the relative path ever leaks out, you've then lost this kind of the resolvable link. But anyway, this approach is still treated as experimental. So Jamie, this is quite a good example because it sort of shows the context that this program is run in, and because it's a side program, not everything is available in the Clojure core. Quite a lot is, actually everything in Clojure core, but you can't exit, you can't do a system exit, you can't do anything with threads, you can't make network calls or anything like that. Well, you can't in the transact. You can do a bit more in the prepare, but the prepare can't access the database because it can't guarantee that the database will be fresh. So yeah, so I've gone quite deep into like XD transaction functions, and I've found them to be kind of really useful for this kind of linearizable consistency. I think if you do anything with access control, you're really dealing with domains that are very sensitive to mistakes. They want access control because they don't want a document being looked at by somebody who's unauthorized, and they don't want the excuse that we unauthorized them but not in time for them to look at the document. You really want this kind of very consistent, principled flow of why you made decisions, and to be able to go back to, why did you let Bob in? Well, because at this point his password was valid or he had the role. So to be able to tell the auditor stories that make sense rather than fill it full of excuses about latency and inconsistency. Jamie, does that answer your question?
Yeah, no, that does answer my question. Thank you. And if we wanted to, so the repository is linked there, so
it's a site.
But how are you doing in terms of the documentation? I know that's kind of a boring question maybe, but is there a lot of documentation on how to use it, guidance or whatnot?
No, there is quite a lot of information in. I put a PDF together. I don't know if it's actually checked into the repo. No, but I have on the site Slack circulated a PDF. There is a PDF that you can build that kind of goes into what actions are. It's a little bit out of date and I need to refresh it. I think the right way to go is this kind of an online client static site generated documentation site that Alex has built for site one. And, you know, it would be quite good to work with Alex to produce some really good documentation for this.
So it's not up to date, but it's like it's there. It's quite relatively similar to site one.
Yeah, the PDF is quite up to date in terms of the concepts are the same, but you learn more by reading the code. There is like 3,000 lines of code, but most of the code is around this big handler thing that you don't really need to know about. So if you just try and get your, you know, play around with it and then try and figure out how it works, that will be more illuminating than reading the docs at this stage.
Yeah, great.
Any other questions, just feel free to reach out to me on Slack. Thanks, Joe.
Great. I don't see any more hands up. So yeah, thanks everyone for coming along. Cheers all.